Let's start with a quick 2,000-year history of atomic theory. Democritus, back in 460 BC, came up with the theory that all things were made of atoms, which were indivisible, and between the atoms was empty space, and they would hook together with various hooks, ball and socket joints, etc. And the key thing was all atoms were different. For example, iron would be made up of very strong, very tough atoms. Water would be very slippery, very flowing type atoms. So they all had different shapes and qualities. Dalton then came along in 1803 with his postulates that once again elements are made of small particles called atoms. They are indivisible, and all atoms of a given substance are identical. Okay? Atoms cannot be subdivided, created, or destroyed, and you can combine the atoms in different ratios to form other substances. Then we came up with Thomson, which was discussed in the last unit, with his plum pudding model, where there is structure within an atom. We had these electrons all placed randomly within a smeared out positive charge, kind of like a British plum pudding. And then up to Rutherford in 1912 with the atomic nucleus right here, and electrons orbiting around it. Through the work of many physicists and chemists, it was established, and this was shown in the last unit, that atoms are made up of protons, neutrons, and electrons. Most of the mass is in the protons and the neutrons, and they're in a very small nucleus, and this was the gold foil experiment from Rutherford. The electrons are outside the nucleus and occupy almost all of the atom's volume, but very little of the mass. Protons and neutrons are way heavier than electrons, almost 2,000 times heavier. And actually the number is 1,836. Protons have a charge of +1, neutrons are neutral, and electrons are -1. The protons and the neutrons, we're going to look at them as stationary in the center of the atom, forming its nucleus. Although nuclear physics shows that the neutrons and protons have many energy levels that are not quite as stationary as you might think. But then again, we have the electrons moving around very rapidly, and their location is never certain. They form something called an electron cloud about the nucleus. To show what the atom looks like, we're going to use this chart. Let's say the nucleus has a relative diameter of 1. That means it has a relative volume of 1, right? You just cube your radius. Volume, of course, is 4/3 pi r cubed. An electron, we're going to say, has very small diameter compared to nucleus, so it has a relative volume of 0. Now the atom, compared to the nucleus, is 10,000 times as wide. Its diameter is 10,000 times the diameter of the nucleus. So its relative volume is 1 times 10 to the 369/12th. Huge number. So the volume of the parts of the atom, right, the nucleus has a relative volume of 1, the electron almost 0. They're minuscule compared to the volume of the atom, which comes up with this: atoms are mostly empty space.